Okay, let's talk about the sum of arithmetic progression. So now the first thing is the general formula. There are actually two formulas for sum of the first n term of arithmetic progression. Is given by Sn equals to n over 2 a plus l, l being the last term, or Sn equals to n over 2 2a plus n minus 1d. Now let's start with the simple one. Let's say you have an arithmetic progression. Maybe you start with 30, 31, 27, 23, and so on. Now in this case, your a is 31. Your common difference is 27 minus 31, which is negative 4. And let's say you want to find the sum of the first, let's say, 7 terms, we can use 7 over 2. I'm using this formula here because you know your a, you know your d, common difference in your first term. Your formula is 2a plus n minus 1 is 6, d is negative 4. So just use your calculator. 62 minus 24, that will be 38. Yeah, 38. Then you divide to 19 times 7, 8, 20 times 7 is 140, 133. Okay, so this is one way of finding the sum. Now sometimes they may not give you the number of terms. Yeah, here I'm finding the sum of the first 7 term. So let's say they give us, let's say I give another example, 7, 11, 15, say until 59. Now you don't know how many terms you have, but we do know that your last term is 59. So in this case, you have to find your n, the value of n first. I know my a is 7, my common difference is 11 minus 7, which is 4. My last term dn is 59. So we use a plus n minus 1 d equals to 59. So we take 59, you minus 7, you divide by 4 plus 1. 59 minus 7 is 52, right? 52 divided by 4 is 13. 13 plus 1 is 14. So now you have total of 14 terms. So we want to find S14. So use n over 2. Now since I know the last term L, so I'm going to use a plus L. So this is 7. This will be 66. So when you add up 4 to 4, 6, 2. Okay. Right. So let's move on. The next part. So sometimes it may give you, okay, things like, okay, find the sum of all multiple of, say, 17 from, let's say, 300 to 800, let's say, something like this. So this one you have to use a calculator because we need to find out which is the first multiple of 17 more than 300. Say, let's take 300 divided by 17. I got 17.6. If you get 17.6, we should take 18. Take the next number. Take 17 times 18. And 17 times 18 will give us 306. That means the first multiple of 17 more than 300 is 306. Now, how about the last multiple of 17? Take 800 divided by 17. I get 47. Now, here you actually get 47.1, but we need to take a smaller one, not the bigger one. The last term is the n. Take 17 times 47. Because if you take 48, then it will be more than 800. This is 799. So that means I have a progression here that works like this. 306 is the first term. The next term we plus 17 is 3, 2, 3, right? Then, and so on until the last one is 799. So we need to find out how many multiple of 17 you have. So a is this, n minus 1. My common difference is 17. The result, dn, must be 799. So to find n, we take 799 minus 306 divided 17 plus 1. 799 minus 306 divided 17 plus 1. Just key in your calculator. My n is 30. So they are altogether 30 multiple 17 from 300 to 800. So to find the sum, we just take S30 The formula, remember, is n over 2 a plus l. My a is 306, my l is 799. Yeah, this is easier actually. A plus l is an easier formula to use. You will get 16,575. Okay, now the next part. Sometimes we may want to find Tn from Sn. And remember, what is Sn? Sn simply means sum of the first n term. For example, you may have T1, T2, T3, let's say T7. This is S7. And if you want to find T8, basically take S8 minus S7. For example, T8 is just S8 minus S7. Right. If I want to find T15, I take S15 minus S14. Okay. So assuming you're given, let's say, example, you're given Sn formula. My Sn is, let's say, 2n squared plus 5n. Just an example. So if you want to find, let's say, T5, we'll just take S5 minus S4. In this case, it's 2, 5 squared plus 5, 5. Substitute inside 2, 4 squared plus 5 times 4. Okay, this is 25 times 250 plus 25, 75. 4 squared is 16 times 2, 32. 32 plus 20, 52. So you get 23. Okay, now what if you want to find the first term? Well, remember, first term is actually S1. I know it sounds weird. S1 is what? S2 is sum of the first two terms. S1 is sum of one term. That means your S1 is the same as T1. So if you sub 1 inside, you should get 7. Now what if I want to find a common difference? Well, to find a common difference, we can use T2 first, S2 minus S1. My S2 is, put 2 inside. S1 I know is 7. So this is 8, 18 minus 7. Right. What do you get? 11. But my common difference is not T2. My common difference is 11 minus 7, T2 minus T1, which is 4. There's another way to find Sn, to find Tn without finding S1. We take Sn minus 1, but this is algebra method, a bit annoying because you have to expand 2n squared plus 5n, you minus 2n minus 1 squared plus 5n minus 1. Okay, so when you expand this bracket, this will be 2, okay, n squared minus 2n plus 1. This is 5n minus 5. Okay, let's simplify the bracket. 2n squared plus 5n. This is minus 2n squared plus 4n minus 2 minus 5n plus 5. Now we can simplify this. Cancel out. So you get 4n plus 3. I have another shortcut to do this. We also know that Sn equals to n over 2 a plus l. My Sn in this case is, I'm going back to this question, 2n squared plus 5n. My a T1 is the same as S1. So let's say we know this is my S1. Yeah, my last term is Tn. I don't know what's my last term, but we can actually cancel this. See, the n we can take out. This is 2n plus 5. This is n over 2, 7 plus Tn. So when you cross out the n, because n cannot be 0, multiply over, you get 4n plus 10 equals 7 plus Tn. Well, my Tn is also 4n plus 3. Notice it's the same thing, right? Okay, so there are many ways you can find Tn from Sn. Alright, so another one is finding the sum from Tm to Tn from Sn. Now, we know that if, let's say, your T1, T2, T3, T4, T5, T6, T7, something like this. Okay, maybe I want to T8. This is the sum of the first 8, S8. This is the sum of the first 3 term. Okay, let's make it S4. S4, sum first 4 term. Okay. If you want to find T5 to T8, basically we take S8 minus S4. Why? I need to cross out this to get this. So if you want to find T7 to, let's say, T20, I'll take S20 minus the term before 7, S6. If you want to find Tn to Tn, we take Sn minus Sn minus 1. Okay, let me give you an example. Let's say you have a progression, let's say 17, next one 23, 29, and so on. So if I want to find sum from, let's say, the 7th term to the 12th term, so we can use S12 minus S6, right? So my S12 will be what? My A is 17, my D is now 6, S12 is 12 over 2, 2A, N minus 1 will be 11, D is 6, S6 is 6 over 2, 2A, 17, N minus 1 will be 5, D is still 6. Okay, but this number is a bit big. You have to count 34 plus 66. This will be 334 plus 30. Big number to count. So this is 6. This is 90, 100. 100. This is 64. 600 minus 192. 408. Okay, there's another way though. We can actually find out the 7th term first. For example, a T7 we know is A plus 6. N minus 1 is 6. My D is also 6. So 17 plus 36. This will be 53. If, let's say we start counting from the 7th term. Now, 7 to 12. How many numbers are there? You got to think 12 minus 7 plus 1. So there are 6 of them. You need to count the 7 itself. You cannot say 12 minus 7 equals to 5, because if you use your finger, 7 to 12, they are 6 numbers, not 5 numbers. So let's count the sum of the next 6 term starting from T7. So we use n over 2, 2a, my a is now 53. We start counting from 53. N minus 1 is 5, d is still 6. So this is 3. This is 106 plus 30. So you get 3 times 136. So you get 408. Same answer, 408 as well. Okay. Now, sometimes you're given the sum and you have to work backwards to find the number of terms. For example, if let's say you have 8, 11, 14, and this sum is 148. So now you'll work backwards and find the value n. So we know our first term a is 8, common difference is 3. So use n over 2, 2a plus n minus 1, d is 3. Result is 148. So this number is a bit big, so we get to times it over. This is 16 plus 3n minus 3. 4244, 432. Sorry, 436. So let's simplify this. This is 13n, 436. Sorry for choosing a big number here, right? Just choose some random number. The number is very big. So a bit hard to figure out the factor here. Can we factorize? Maybe I've made a mistake. Okay, sorry, I made a mistake here. 148 times 2, not times 3. I go in times 3. So it's 296. 296. So 296 can simplify. Can, but the number is a bit bigger. 296. So we can factorize. So 3n. Take 296 divide by 8, 37. So this should be 837. So that 37 minus 24 gives us 13. Okay, so n is always more than 0, n should be 8. Okay, all right. Now, last part. What if you're given the sum and the first term? sorry, let's say for example you have the sum of the first 6 term of the first 6, let's say is 120, and the fifth term is 29. Let's say you want to find the first term and you find the common difference. So here we have to form two equations, as 6 is now 120, so n over 2a, n minus 1 is 5, d results 120. So for me, I'll just take 120 divided by 3, 40, first equation. The fifth term is now 29, use the formula a plus n minus 1d is 29. So I'll take this equation at times 2, so I get 2a plus 8d equals to 58. Now reason being, I want to eliminate a with the equation 2 minus equation 1, 2a minus 2a cancel out, 8d minus 5d is 3d, 58 minus 40 is 18, d is now 6. So when you sub inside, let's say equation number, actually I should call this equation number 2, this equation 3. So equation 2, so this is 3 minus 1. So a plus 4 times 6 is 29. 29 minus 24, a is just 3. A is just 5, sorry. Okay.